Good morning, everyone. It's really my pleasure to be here. My name is Paul Ohm. I'm from Georgetown University in Washington, D.C. I'm in the third year of my support from AXA, and I've never had the opportunity to come to Paris. I've been kind of an ungracious recipient of the AXA Research Fund's beneficence. And so I will say with this first opportunity, what I'm sure Dr. Ford and Dr. Deng would like to say as well, although I get to go first, which is it really has been transformative for my career to have the kind of support and really the unqualified support from this corporation. It really is, from my American eyes, kind of an unusual thing. There aren't American corporations that I can think of that kind of in this really intellectually honest way really do seek an interaction, a true interaction between academics and the important work you do. And so it's really just a great honor to be here and to thank you personally. And I've been treated really well this week, so thank you for that as well. There was kind of a strategic choice in the ordering of these two talks because as maybe evident to especially those of you from the United States, but even not, we don't really have a lot of privacy and data protection law in our country. And because of that, there really are kind of two ways you could respond. You could respond by clamoring for a more European model, which certainly a lot of people do. Or you could also just spend your time obsessing and worrying about the law that we don't have. And I'll confess that most of the time I find myself in that second camp. As a little bit of background, I've served as a government regulator in the Federal Trade Commission. I've served as a federal prosecutor in the Department of Justice looking for computer hackers. And I'm also a kind of, fake computer scientist who writes a lot of code. And so the work that I do is really at the hard intersection of law and technology. And, there's a lot to see in that relationship that causes a little despair. And so what I'm going to do is probably talk a little bit more pessimistically about some of the challenges that underlie what Dr. Wendling just said in her extremely well-received remarks. We could have flipped the order and probably ended on a more optimistic note, but let me follow me into the pits of despair as I talk about pessimism. These are actually kind of a capsule summary of two of the papers that I've written with AXA support. And so the citation is there at the bottom of the slide, is a chapter in an edited volume called What If Everything Reveals Everything? And Dr. Wendling already suggested in her presentation this idea that this kind of concept of personal data, one that is really an underpinning of a lot of European and other law, has started to break down. And I wanted to just give a little substance and even some research results that add some flesh to those bones. And so here's my crude indicator of what we do when we protect privacy in law. And interestingly, this isn't just an American story. What we do as an enterprise of making laws around privacy is we draw lines. We look for things we can categorize as different, as the break point between that which we regulate and that which we do not. And so here are some examples. We tend to think of things like personally identifiable information, or PII, in the directive, and I believe in the GDPR, this is the concept of personal data or personal information. And we draw this hard line which kind of says, if you fall within this category, you're regulated. If you don't, you're not. We also think about things, and Director Thiemann mentioned this in his remarks, sensitive versus non-sensitive information. And we ask people to undertake this game of saying, well, how can this impact a human being, especially in terms of potential harm? And if we think the data is the kind that causes harm, we regulate, otherwise we do not. Or in the European context, we regulate more when it's sensitive. This third one is a really American take on things, which is we really look at the sector in which the data is obtained or used, and we apply different rules based on that sector. And in many cases, we apply no rules whatsoever, and I'll get more into that later. Fourth, we say some actors are covered and some are not. The best example of this under American law is we have something called the Health Insurance and Portability Act, HIPAA. HIPAA applies if you're a hospital gathering data. It applies if you're a doctor or an insurance company gathering health data. It doesn't apply if you are Google or Microsoft or the creator of an app obtaining the exact same data. And so that's a line we've drawn in American law, which, again, I think sounds probably crazy to European students of privacy law. And then last but not least, in America, we have this concept born out of discrimination law that there are certain classes or categories or characteristics of people that are especially sensitive: race, gender, ethnicity, increasingly sexual orientation, and we will not let you make distinctions based on suspect class, but we will based on non-suspect class. And so a fundamental premise of what I kind of stand for in my work and have tried to bring to people in law and policy in the United States is the idea that these lines are evaporating, that this idea, this neat and tidy version of the world is disintegrating. So here's one example of many I could give. We now are well aware of the kind of traditional indicators of identity. So for example, we know that fingerprints reveal a uniqueness in every one of us, and if kind of extrapolated and analyzed, we might be able to learn things about identity. It turns out fingerprint science is not nearly as good as some people think it is, but it's still an indicator of unique identity. Biometrics are increasingly a way that we kind of pluck identity out of people and data, and then this is the idea of you can even tell through gait analysis the kind of unique human being that stands before you. And so based on kind of these heuristic ideas of what gives away identity, we've constructed privacy law that says, if you don't want to be regulated, just remove the identity. Remove the fields of information from your data set that kind of help you attribute data to an individual. Remove name, birth date, postal code. And once you've removed those things, then what's left behind is both protected under data protection and privacy law, and also really useful for your analytics. Now, I hope you're already appreciating the kind of tension that you no doubt have thought about. For example, as soon as you remove the postal codes, you've lost something that you would use to, for example, base a risk assessment on that might help you price an insurance product. And so there's this tension even in this neat and tidy indicator of the world, but it still worked for the most part for about 100 years. We were happy with the way this worked. But the core thesis of what we talk about in this paper is that this has just begun to evaporate. I've chosen my favorite result. This isn't my work, this is the work of others, but it's not the only one I could have chosen. I chose it also because I think there's a relevance to probably what you do when you think about, for example, outfitting cars with black boxes to assess auto insurance risk. So this is work out of MIT, Professor De Montoya, and what he has done is he has taken an anonymized, that's the key word, set of cell phone registration location information, and he's taken that and he's asked, is there really anonymity in this data? Can we really analyze this, for example, to assess some sort of risk? Or is it possible that with a tiny bit of outside information, you can actually re-identify everybody in that data set? So he used an anonymous European country and was able to access the one telecom provider's cell tower registration information. There is a prominent thank you. I just noticed this last night while preparing for today. There's a prominent thank you in the acknowledgement to the government of Belgium. So I wonder if maybe I've re-identified this country. And what he's done in his research is he has said, if I were to randomly choose an individual's two data points in that data, right? What are the odds that they are the only person in the entire data set with those two data points? And so this is kind of typical of this work. We take this supposedly anonymized data, we ask ourselves, how much uniqueness is there really left behind? And the reason we're doing this, of course, is because we want to triangulate, we want to correlate this data, this anonymous data, with outside information that we could bring to bear to help re-identify. And if nothing else, the one result that I kind of want policymakers to understand, I think the computer scientists are beginning to understand this, is our intuitions are always off when it comes to a study like this. And prior to kind of releasing the results of the study, if you said, how much cell site information would I need to know to uniquely identify most of the people in Belgium? People might say, well, I don't know, maybe you need to follow the person around for 2 days or 3 days, and then you'll begin to see the kind of uniqueness in their activity. But quite to the contrary, what we have here, if you look at this kind of overly complicated chart, is that the green bars indicate the percentage of the people in this country who are uniquely identified based on the numbers at the bottom. This is how many individual data points you need to uniquely pluck someone out. And so if you have 2 single data points of location data about an individual, you will uniquely identify them 51% of the time. If you have 4, you'll uniquely identify them 95% of the time. And then the box and whisker plot on the right shows that if you know 11 data points, you've uniquely identified every single person in that entire data set. Now, remember what this means in terms of a threat model. You associate your phone with the cell tower approximately, in this data set, approximately once every hour. So if you follow a single individual, say your best friend or worst enemy, for 1 hour, and you get the data point at the top of the hour and the data point at the bottom of the hour, you'll uniquely find them in this data set 51% of the time. And what can you do with that information? You now know 5 years of where they've been every hour on the hour, right? If you follow someone around for, I guess this would be 3 hours, 95% of the time, that's all you need to do to uniquely identify them out of the entire data set, okay? And so what is the kind of import of work like this? The import of work like this is it is much, much, much more difficult to make privacy assurances than we thought before an avalanche of research. This is only one of dozens of studies I could have exemplified for you. Let me just, in capsule summary, talk about other things that uniquely reveal identity. So we know cell site location does. The most famous study probably in this entire space is if I know 4 movies that you've rented on Netflix, I probably have approximately all of the movies that you've ever rented on Netflix, right? That was the one that kind of broke up in awareness in this field. There's a study out of the Electronic Frontier Foundation in America that asks how unique is your browser? Because we know that kind of third-party advertisers use cookies to re-identify you, but if you block cookies, can they still, by just interrogating your browser, know who you are uniquely? And the answer is yes, and the thing that gives you away is your fonts. The particular selection of fonts that you have on your browser is very likely uniquely situated compared to everyone else in the world, or at least everyone else who visits that website. So even with your cookie blocker turned on, if you haven't also blocked all other interrogation of your browser, you're probably still capable of having a behavioral profile built against you. Now, that might be a very American way of looking at things. The data protection people in the room would say, but that will be illegal under European law. This is why I dream of being European someday. The one that really I found most kind of stunning and chilling comes out of Princeton University. They analyzed the little scratch-in bubbles that you do on things like standardized testing and ballots. And this is granted a limited study, and they are kind of reluctant to make grand pronouncements about their results. But they found in their limited study that 51% of people with a very, very basic machine learning technique can be re-identified from the way they shade in the bubbles. And if you want to narrow someone down to a group of 2, it's more like 75% of the people. Right? This is a problem because in many American jurisdictions, we take our supposedly anonymous voting ballots and we put them on the web. And so if this is true, all you need to do is get a sample of other bubbles people have filled in, and you'll know how they voted in every election in their jurisdiction to the beginning of time. That's a problem, right? Okay. So the kind of main thrust of the paper, and I want to get to the second paper, so let me do this kind of briefly, is that if you look at beyond identity to other things that we might consider important or sensitive, you're going to find this result applies frequently. And so on the right, I kind of have a little indicator of your credit score in the United States, the idea that we can come up with a single number to measure your credit worthiness. Well, me and my co-author, I should have mentioned Scott Peppett, is a co-author on this project. We think that probably everything you do is correlated with your credit score, plus or minus some error. And my favorite example of this is the Canadian bank that did a quick study and said, if we throw out everything we know about our loan applicants except one piece of information, do they buy the little pads to protect hardwood floors from furniture? And we gave loans only to people who did this. Turns out we'd have almost the same annual returns on our loans than all the other data we look at, right? So every little thing you do reveals everything else you do. And so the question is, if this is the world we're heading to, what does this mean for data protection? If every little rich data set that we can gather about you, the color of your shirt, whether you eat with your left hand or your right hand, if all of those things reveal everything else that's meaningful of you, which of course in the extreme cannot absolutely be true, but in this chapter we pose the kind of thought experiment that even if it's somewhat true, what does that mean for the kind of pursuit of data protection? And I'll have to be honest, we leave it as a bit of a cliffhanger, right? I mean, there are several paths you can take, but they're all somewhat in despair. One is we give up on the project of data protection altogether. Another is that we give up greatly on the utility of our data sets, or we have a heavy regulated world where it's much, much, much more difficult to do the kind of useful data analytics that we'd like to do. Those are our choices, so you're welcome for that optimistic list. Okay. This is actually, so when I heard Director Thiemann gave his comments, I couldn't believe how in line with this next slide one of his comments were. He talked about the kind of trade-offs between utility and privacy. And that's exactly, one of the things I've done. I actually didn't create this slide, I annotated it. So this is a slide that I saw presented once that I found quite compelling. So what we have here on the x-axis is information, how valuable the information is, ranging from no information, if we just deleted all the data, to optimal precision, lack of bias, the kind of holy grail of what data scientists want. And on the y-axis, if we take the same data and we range it from no protection whatsoever from privacy violations or privacy invasion to complete protection, too often regulators in our kind of capitals around the globe imagine that there's this point up here in the far upper right of this plot where we have it all, where we have perfect privacy protection and perfect data analysis. But the dashed lines indicate that this is just illusory, that you really never can have all of that. In an article that I wrote 10 years ago, I said that data can either be perfectly anonymous or useful, but never both. And a lot of people kind of reacted strongly to the strength of that. I stand by it today. It's, I think, actually a kind of boring, almost tautological statement. I did propose at the time that we call it Ohm's law, and someone pointed out that that was taken already. Okay, so at any rate, the gentleman who created this slide, he imagined this kind of orange manifold, this orange curve, which depicted the real state of the world, where we're in this constant kind of struggle of trade-offs, where we're gonna have to, in the name of data protection, either because a regulator tells us to or because we think it's the right and ethical thing to do, lose some of the utility of our information. And at some point, what we're really trying to figure out, according to the gentleman who created the slide, is whether we ought to be here or here or here. I sometimes despair, and I get this from reading studies like the cell site study, that this is the real curve of the world, and that the trade-off is actually just a very, very, very bad set of compromises, and that in order to improve our privacy even a little, we actually have to give up on quite a bit of utility in the data. And it's an open and empirical question. Obviously, there's no real data. This is kind of merely illustrative behind this chart, whether we're on the orange curve or the reddish curve or somewhere in between. But the one thing we all know for sure is there is no dotted curve. Okay, so the last thing I want to do, and I only have a few minutes left, so let me do this quickly, and I would invite both Q&A and during the speed dating session, more of a discussion of this. This is the second paper I've done with Access Support, Regulating Software When Everything Has Software. My co-author on this is Professor Blake Reed. And so it also gives me an opportunity to tell you a little bit about American privacy law for those who have not been exposed to it. So the bottom line you need to know about American privacy law is we have no what we call omnibus data protection law that covers all industries. Everything is done on a sector-by-sector basis. And most importantly, there really is no single regulator to cover companies like Google, Microsoft, Facebook, which is a problem in Europe when it comes to the activities of those companies and what happens when the data is transferred back to the United States. So I'm sure many of you have followed the Schrems case. In Europe, we have followed that quite closely and what it's done to the Safe Harbor and Privacy Shield. What we've done in the paper is we've said one problem that's looming is that right now these are the logos of 4 American agencies. The Federal Communications Commission handles telecom, the FAA handles these big planes, the FDA medical devices, Food and Drug Administration, and the National Highway Transportation and Safety Administration, which was quite obscure, handles auto safety. Okay. But what, again, borrowing from the work of other people I've done, and since I have no time, let me just show you this quickly, is researchers out of Stanford did this fascinating study where they looked at where innovative words come from in the American patent law corpus. And so this is the year that a word first appeared in the patents of America, sorted by how often those words were later cited. And the most important thing is the color code. What you want to see is that you go from yellow and blue and black in the 1880s, 1890s, 1900s, which indicate things like electrical, chemical, and other. And by the time you get to the 2000s, it's green for computers and red for medical. And so the point we make in our paper is that what we have is we have a transition from the world of atoms to the world of bits. And among other things, what it's done to the American system is it's meant this one device, this smartphone, suddenly is now the purview of all 4 of these agencies. So for example, the FDA has taken to regulating apps that supposedly you can point at your mole on your skin and determine whether or not you might have a melanoma. That's a medical device under their interpretation, but it never was something that they had the capability or the history of regulating in the past, which gives rise to all sorts of conflicts between and among agencies. Okay, so once more with gratitude, thank you very much for your time. I appreciate it.